Hello. Today we're going to be talking about how to do roots, specifically how to simplify them. So the symbol for roots looks like this, and there's a number right there. And like I just said, the goal for today is by the end of this video, you should be able to simplify the root of a number. The number goes into this part right here. So exactly how do you simplify the root of a number? First thing you need to do is you need to be able to find the prime factorization of whatever number is right there. Let's do an example. So let's say, for example, you have this, the third root of 87,808. So there are two ways that I've explained how to do prime factorization of a number. First way is called the tree method. What you do is you start off by writing the number you want to do the prime factorization for. Then you find two numbers that multiply to equal that. If these numbers are not prime, then you just have to find two more numbers that multiply to equal that, etc. You keep on doing this until the number at the very end of your branches are all prime numbers. So those would be all prime. Another way you can do the prime factorization is the ladder method. In the ladder method, you start off by writing the number you want to factor in the top right-hand corner. And you divide it by prime numbers until you get to some point where all the numbers here and at the end are prime. So you stop when this last number here becomes prime. If you don't remember how to do that, I will link the videos where I explain these two methods in the description below. So at this point, I want you guys to pause the video, try to do the prime factorization of 87,808, and write down whatever notes you want from this. Continue with the video, press play when you're ready. Okay, so regardless of which method you decide to use, the third root of 87,808, we should have gotten that was 2 times 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 2, 8 times. And then 3 sevens. All right. So once you've finished the prime factorization, step 2. Step 2, you are going to be, here's our example, you're going to be pulling out groups of numbers. How big of a group of numbers you're pulling out will depend on this number right there. So because that number is a 3, you're going to be pulling out groups of 3 from the inside here. So I see a group of 3 2s. So I pull one out. I see another group of 3 2s. There's this multiply symbol in between, so like that. Okay. There's no more groups of 2, no more groups of 3 2s. So we'll move on to the next number. I see a group of 3 7s. So all of those go from inside of the root to outside. And then what is left inside is 2 times 2. So this is equal to this. And I mean, this whole thing is equal to this whole thing. Of course, at this point, you could simplify this. 2 times 2 is 4, times 7 is 28. And then, oh, by the way, there should have been a 3 here, my mistake. And then 2 times 2 is 4, so 28 cube root 4. There's a multiply right here, which a lot of times people do not write. If you want to write it, you can, but if you see the 28 right next to this, it means multiply. Pause the video right here. Take notes on whatever parts is helpful for you. Okay. So why does this work? That's the next part I want to talk about. Exactly why does this work? So let's do an example. Let's say that you have the third root of 8. And you know that's equal to something. I don't know what it's equal to, so I'm just going to represent it with this box. So third root of 8 is equal to something. Okay? Another way you could write this right here is the same as eight equal this red box to the third power. These two lines are equal. What I did to go from here to here is I did exponent 3. So this to the third power equals this. And that's because root 3 and to the third power are inverse operations or opposite of each other. And third root of this box just becomes box third root. Sorry. This to the third power just becomes box to the third power. So these two things are the same or equal to each other. So if I wrote this with the prime factorization of 8 is just 2 times 2 times 2. And so if I was writing it in this way, it'd be 2 times 2 times 2 is equal to something to the third power. You can think of this third root symbol as you are looking for something. You're looking for something that when you do exponent 3 to it, it equals that number inside. So this number in here times itself 3 times should equal the number that's inside. Okay? So obviously the thing that to the third power equals 8 is 2. So 2 times 2 times 2 equals 2 to the third power, which is why the cube root of this is equal to just 2. One extra thing I want to note is if you end up seeing a root symbol with no number here, that's the same as there being a 2 there.